The UL listing for electrical equipment is voided if a knockout is made in a panel unless it is specifically permitted and labeled by the manufacturer. Knockouts should not be made in areas where they may compromise the integrity or safety of the equipment. Regarding junction box gutters, knockouts are generally not permitted if they are located at the ends of the gutter, within 6 inches of the ends of the gutter, or within 2 inches of the sides of the gutter. For antique equipment, each case should be evaluated individually, taking into account the age, construction, and condition of the equipment. If unsure, consult with a qualified electrician or regulatory body. When making knockouts, knockout tools should be used to create clean, burr-free holes. Always follow the manufacturer's instructions and knockout dimensions precisely. Deburr the edges of the knockout hole to prevent sharp edges from damaging wires or insulation. Utilize appropriate bushings or grommets to protect wires passing through knockouts. Employ proper sealing methods, such as gaskets or caulk, to maintain the integrity of the enclosure. To elaborate on the UL listing, Underwriters Laboratories provide safety standards and certifications for electrical equipment. Modifying equipment in a way not intended by the manufacturer can compromise its safety and invalidate the UL listing. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. It's important to consult the latest edition of the NEC for specific requirements related to knockouts and enclosures. When working with junction boxes, the NEC specifies restrictions on knockout placement to maintain the structural integrity and prevent moisture ingress. The NEC addresses the installation and use of electrical boxes and enclosures. This includes requirements for the size and type of box or enclosure, the number of conductors allowed in a box or enclosure, and the methods for securing conductors to boxes and enclosures. For instance, NEC Section 314.16 covers the number of conductors in outlet, device, and junction boxes, while Section 314.17 discusses the methods for securing cables to boxes. With antique equipment, safety is paramount. The insulation may be deteriorated, and the wiring may not meet modern standards. Exercise extreme caution and seek expert advice before making any modifications. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Inspect the equipment for any signs of damage or deterioration before proceeding. The integrity of an electrical enclosure is critical for safety. It protects against electric shock, fire hazards, and environmental factors. Making unauthorized knockouts can compromise this integrity. Ensure that all unused openings in electrical boxes and enclosures are properly closed with suitable plugs or covers. This prevents the entry of dust, moisture, and foreign objects. When selecting knockout tools, choose the appropriate size and type for the specific application. Using the wrong tool can damage the enclosure and create hazardous conditions. There are several types of knockout tools available, including manual knockout punches, hydraulic knockout punches, and step drills. Select the tool that is best suited for the size and type of knockout required. When using knockout punches, ensure that the die and punch are properly aligned and that the tool is securely fastened to the enclosure. Follow the manufacturer's instructions carefully to avoid damaging the equipment or injuring yourself. After making a knockout, carefully deburr the edges of the hole to remove any sharp edges or burrs. These sharp edges can damage the insulation of wires or cables, leading to short circuits or ground faults. Use a deburring tool or file to smooth the edges of the knockout hole. When installing wires or cables through knockouts, use appropriate bushings or grommets to protect the conductors from abrasion. Bushings and grommets are available in a variety of materials and sizes to suit different types of conductors and enclosures. Select the appropriate bushing or grommet for the specific application. When sealing knockouts, use a suitable sealant or gasket to prevent the entry of moisture, dust, or other contaminants. The type of sealant or gasket required will depend on the environment in which the equipment is installed. In wet or damp locations, use a waterproof sealant or gasket. In dusty or corrosive environments, use a sealant or gasket that is resistant to these conditions. It's important to maintain the proper grounding of electrical equipment. Knockouts can sometimes affect the grounding path. Ensure that the grounding conductor is properly connected to the enclosure and that the grounding connection is secure. Consult the NEC for specific grounding requirements. If you are unsure about any aspect of making knockouts in electrical equipment, consult with a qualified electrician. Electrical work can be dangerous, and it's important to follow all safety precautions. Always prioritize safety when working with electricity. We remember that electrical codes and standards are constantly evolving. Stay up to date on the latest requirements to ensure that your work is safe and compliant. Consider attending continuing education courses or workshops to enhance your knowledge of electrical codes and best practices. Understanding the principles of electrical safety is essential for anyone working with electrical equipment. Learn about the hazards of electricity, how to protect yourself from electric shock, and how to prevent electrical fires. Electrical safety training is available from a variety of sources, including trade schools, community colleges, and online training providers. Proper planning is essential before making any modifications to electrical equipment. Assess the existing conditions, identify any potential hazards, and develop a detailed plan for the work to be performed. Obtain all necessary permits and approvals before starting work. Communication is key when working on electrical systems. Inform others who may be affected by the work, and coordinate with other trades to avoid conflicts or delays. Clearly label all circuits and equipment to prevent confusion. Documentation is important for maintaining accurate records of electrical work. Keep detailed records of all modifications made to electrical equipment, including the date, description of work, and any relevant test results. Store these records in a safe and accessible location. Regular inspection and maintenance are essential for ensuring the continued safe operation of electrical equipment. Inspect equipment regularly for any signs of damage or deterioration, and perform any necessary maintenance or repairs. Follow the manufacturer's recommendations for maintenance intervals and procedures. Remember, working with electricity can be dangerous. If you are not qualified to perform electrical work, consult with a licensed electrician. Your safety is paramount. The National Electrical Code, specifically Article 314, covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. This article provides detailed requirements for the selection, installation, and use of these components. Furthermore, NEC Section 110.3 addresses the examination, identification, installation, and use of equipment. It requires that electrical equipment be installed and used in accordance with the manufacturer's instructions and listing all labeling requirements. Consider the environment where the electrical equipment is located. Is it a wet location, a dry location, or a hazardous location? The NEC has specific requirements for electrical equipment installed in different types of locations. For example, equipment installed in wet locations must be listed for wet locations. Also, consider the type of wiring method used. Are you using conduit, cable, or another wiring method? The NEC has specific requirements for each type of wiring method. For example, conduit must be properly supported and secured. When making knockouts in enclosures, be aware of the potential for electromagnetic interference or EMI. Knockouts can create openings that allow electromagnetic energy to escape or enter the enclosure, which can interfere with the operation of sensitive electronic equipment. To minimize EMI, use shielded enclosures and ensure that all openings are properly sealed. It is also important to consider the structural integrity of the enclosure when making knockouts. Avoid making knockouts in areas that could weaken the enclosure or compromise its ability to protect the electrical components inside. Reinforce the enclosure if necessary. Furthermore, the use of non-metallic enclosures is becoming increasingly common. When making knockouts in non-metallic enclosures, use care to avoid damaging the enclosure material. Use appropriate knockout tools and follow the manufacturer's instructions. It's also important to select the correct size knockout for the conductor or fitting that will be installed. Using an undersized knockout can damage the conductor insulation, while using an oversized knockout can create a gap that allows moisture or contaminants to enter the enclosure. When installing grounding and bonding conductors, be sure to follow the NEC requirements for grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock and fire hazards. Use appropriate grounding and bonding connectors and ensure that all connections are tight and secure. Another thing to consider is the potential for corrosion. Electrical enclosures and components can corrode over time, especially in harsh environments. To prevent corrosion, use corrosion-resistant materials and coatings. Regularly inspect enclosures and components for signs of corrosion and replace them as needed. Ensure that all electrical connections are properly torqued. Over-torquing can damage the conductors or connectors, while under-torquing can result in loose connections that can overheat and cause fires. Use a torque wrench to ensure that all connections are properly tightened. When working with electrical equipment, always be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. To protect yourself from arc flash, wear appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields. Always de-energize equipment before working on it whenever possible. Consider the voltage and current levels of the electrical system. Higher voltage and current levels pose a greater risk of electrical shock and arc flash. Take extra precautions when working with high voltage or high current systems. The National Electrical Manufacturers Association, or NEMA, provides standards for electrical enclosures. These standards specify the environmental conditions that the enclosure is designed to withstand, such as water, dust, and corrosion. Select an NEMA-rated enclosure that is appropriate for the environment in which it will be installed. When installing electrical equipment outdoors, be sure to protect it from the weather. Use weatherproof enclosures and fittings to prevent moisture from entering the equipment. Protect conductors from sunlight and physical damage. In addition to the NEC, other codes and standards may apply to electrical installations. Check with your local authorities to determine which codes and standards are applicable in your area. The International Brotherhood of Electrical Workers (IBU) provides training and resources for electricians. Consider joining the IBU to enhance your skills and knowledge. The National Electrical Contractors Association (NECA) provides resources for electrical contractors. Consider joining NECA to stay up to date on industry trends and best practices. Regularly review your electrical safety procedures and practices. Identify areas where you can improve safety and implement changes as needed. Electrical safety is an ongoing process. Never become complacent. Staying informed about changes to codes, new technologies, and safety practices is important. Continuous learning is the key. Also, consider the load calculations for any new circuits you may be adding. Ensuring that the existing electrical system can handle the additional load is very important for preventing overloads and potential fire hazards. This would normally involve calculating the total load on the existing panel and comparing it to the panel's rating. If necessary, consider upgrading the electrical service to accommodate the new load. When working with older electrical systems, be aware of the potential for asbestos exposure. Asbestos was commonly used as insulation in older electrical equipment. If you suspect that asbestos is present, take appropriate precautions to avoid exposure. Consult with a qualified asbestos abatement contractor. Use properly rated extension cords. Only use extension cords temporarily, never as a permanent solution. Overloaded or damaged extension cords are a common cause of electrical fires. Use ground fault circuit interrupters or GFCIs in wet locations. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. Install GFCIs in bathrooms, kitchens, and other wet locations. Use arc fault circuit interrupters or ASIs to protect against arc faults. ASIs are designed to detect arc faults, which are a common cause of electrical fires. Install ASIs in bedrooms and other areas where people sleep. Make sure smoke detectors and carbon monoxide detectors are working properly. Test them regularly and replace the batteries as needed. Smoke detectors and carbon monoxide detectors can save lives.